In this lecture, we will see one simplification of method for simplification of Boolean expressions, that is Karnaugh map, also called as K map. K map is an efficient method to simplify the Boolean expressions. In K map, we will have to arrange in the for example, we have this truth table. There are two variables a and b and output y. This y depends on a and b. A and b have this combination 0 0 0 1 1 0 1 1, and the value of y is like this for this input combination. Sorry, we will change. Suppose this is the value of y for this input combination. The expression for y can be written in SOP form as y equal to a bar b bar plus y equal to a b bar. This is the expression in SOP form. We can also write this expression in POS form as y equal to, we'll see the 0, y equal to a plus b bar and y equal to a bar plus b bar. Both the expressions can be simplified. This will be b bar will be common, a bar plus a will be equal to b bar, and this expression will be b bar plus a dot a bar will be again b bar. So in both the cases we are getting b bar, but for that we have to simplify this applying Boolean theorems. But if we use K map for this simplification, we can get the simplified form in just one step. First we will see two variable K map. In two variable K map, we will take example of a function which depends on two variables a and b. For this function, a and b will have four combinations 0 0 0 1 1 0 1 1. This will be zeroth combination, this will be first combination, this will be second combination, and this will be third combination. For all the combination we will have different values of f, and these different values will be substituted in a two variable K map. A two variable K map basically looks like this. Inputs are a and b, 0 1 0 1. Zeroth combination will be plotted. Value of f for zeroth combination will be plotted here. First combination will be plotted here, second combination will be plotted here, and third combination will be plotted here. In the truth table shown above, the K map can be solved. This 0 will represent b bar, this one will represent b, this 0 will represent a bar, and this one will represent a. Now these values can be plotted in this K map. For zeroth combination f is 1 or y is 1. For first combination y is 0. For second combination y is 1, and for third combination y is 0 will be plotted here 1 0 1 0. Now these two ones can be covered in a pair. Now this pairing is necessary for writing the simplified expression. There are two ones, and these two ones are adjacent to each other, they can form one pair. See, if these two one were in this position or in this position, pairing cannot be done. Both are the wrong procedure of pairing. If these two ones were in this in these positions, pairing could have done. Now, if a pair is formed in this case, for this pair we will write the simplified expression. F or Y will be written in terms of A and B. For this pair, in this pair we have 2, 1. For both one, the variable either it is A or B should have a single value. For this one A is 0, for this one A is 1 means both the one have different value of A. A will not be considered in the expression. For this one B is 0, for this one B is 0 means for both the ones B is 0, that is B bar. So for the expression will be F equal to B bar. Now in the K map we will have to make the pairing. The pairing can be of 1, 2, 4, 8, 16 depending on the K map. In two variable K map the pairing can be of 1, 2 and 4. We'll take some example and we'll go for the bigger K maps. Simplify f is function of ab equal to summation m 1. We'll simplify this expression. We'll find the expression for f. We'll write the K map. In K map, we will draw a two variable K map, and this given expression represent that f, which is function of ab, has its value logic 1 for first combination, and we know that this block represent zeroth combination, first combination, second combination and third combination. This first combination has logic 1 value, other combination has logic 0 value. So first combination will have logic 1 value. Now in this K map we have only single one. For this single one there cannot be a pair of 2, pair of 4, it will have a single. For this single we will write the expression for f. The f can be written as f. For this one a is 0, for this one b is 1, so it will be a bar b. This is the expression for this. Now next example, simplify f of ab summation m 0 to 3. This expression represents that for zeroth combination, second combination and third combination, the f has logic 1 value. Zeroth combination, second combination and third combination. Now we will start pairing. We can make a pair of this, and now 1 is remained single. Now this one can be covered in single also, but when we cover it in single, the expression we obtained from the K map will again be simplified using Boolean theorems. But K map has a definition that it will give simplest form which cannot be simplified further. So for this we cannot make this single because we have another one in adjacent to that one. So in this case we will combine both these one and will form another pair. Now we can write the expression for f. For this pair a is 1, for this pair b is 0 for this one, 1 for this one, means b is changing and a is constant, so f will be equal to a. Now for this second pair, both the 1 have value of a 1 and 0 means changing, but value of b for both the 1 is logic 0 means will be b bar. So for the for f the expression is a plus b bar. Now the next is three variable k-map. Three variable k-map, for example, f is function of a, b, c, and it has logic 1 value for this combination. Now for finding the expression for this function f, we will have to use three variable k-map. In three variable k-map, there will be provision of substituting 8 combinations. Remember, always MSB will be written here and LSB will be written here. For BC, there will be two values 0, 0. This 0 represents B bar, this 0 represents C bar. Next will be 0, 1. And remember, next will be 1, 1, not 1, 0. Because if you take 1, 0, it will create some problem while pairing and writing the expression for f. And then 1, 0. Here for A, first will be 0 and next will be 1. Now we will substitute the value logic 1 for these combination. Now the first block will represent 0th combination, first combination, and this will represent second combination, and this will represent third combination, fourth, fifth, and this sixth combination, and this seventh combination. Now for this particular problem, we can start simplifying by substituting all the logic 1 in the k-map. For 0th combination, logic 1. For first combination, no. For second combination, it is logic 1. Second combination is here. Fourth combination, it is logic 1. And for sixth combination, it is logic 1. Now in this k-map, we can see that there can be two pairs. But a k-map has another property that it can be folded from this end to this end. If it is folded, there will be 4, 1 adjacent to each other. If there are 4, 1 adjacent to each other, we can have a combination of 4, that is quad. So these two pairs will be converted into a quad. So a k-map can be folded to get 4, 1 together. So this 4, 1 will be called as quad, and for this we will write the expression f. For these two 1, a is 0. For these two 1, a is 1 means a is changing. For these two 1, b is 0. For these two 1, b is 1 means b is changing. For these two one C0, for these two one C0 means F equal to C bar. This is the expression for the given function. Now we will see some more examples. Simplify. If is function of ABC equal to summation M 0, 1, 3, 6. For this, the K map can be plotted as for zeroth combination 1, for first combination 1, second combination, for third combination is 1, fourth, fifth, and sixth combination is 1. There are two 1 adjacent to each other, pairing will be done. There are two 1 again adjacent to each other, pairing will be done. And there is single 1. Now the expression can be written as F equal to, for these two 1, A is 0. A is 0 means A bar. For these two 1, B is 0. B bar. For these two 1, C is changing, not considered in the expression. Plus, for these two 1, A is 0, let's say bar. For these two 1, B is changing, C is constant 1, that is C. Plus, for this A, for this one A is 1. For this one B is 1. For this one B, C is 0. So A, B, C bar. This is the final expression in the most simplified form. Now take one more example. F is function of A, B, C equal to summation M 1, 3, 6, 7. For this, we'll plot the K map as there will be 4, 1 and the place shown. Now there will be one pair here, one pair here, and one pair here. All the 4 ones are covered. Now when we write the expression for this, F will be equal to A bar C plus A B and plus for this one B C. This is the expression. But this expression here there are two variables, three variables A, B and C, all used twice. Only one variable has its complemented and without complemented form. So using consensus theorem, this can be reduced as A, B plus A bar C. So here we can see that we have applied consensus theorem, means we have applied Boolean theorems to simplify it. But according to definition of K-map, the simplified expression which we have which we obtained from a K-map is in its most simplified form, but we have simplified it using Boolean theorems. So this cannot be in most simplified form, means we have committed a mistake somewhere. See, we had 4 1 in the place shown. If we have this one pair, this one pair, all the 4 ones are covered. Means there is no need of this pair. Means this pair is redundant. This pair is redundant. Now if we find the expression, F will be equal to A bar C plus A B. This will be the final expression. Now take one more example. F is function of A, B, C equal to summation from 0, 1, 5, 6, 7. For this, we will plot the K map. For zeroth combination, it is logic 1. For first combination, it is logic 1. Second, third, fourth, fifth combination, it is logic 1. Sixth combination is logic 1. And seventh combination, it is logic 1. Now we'll start the pairing. First, this will be paired. Again, this will be paired. Now, one single one is remained. We can have pairing of these two, and we can have pairing of this two also, but only one of them. So for this K map, we get expression F equal to A bar B bar plus B bar C plus AB, or F equal to A bar B bar plus AC plus AB. So these two terms are different in both the expression. If we take different combination, we will get different answer. So from this we can conclude that the expression obtained from K map is not unique. It is not unique. For same question, we are getting two different answers. So it is not unique. Now take one more example. Now for zeroth combination, it is logic 1. For first combination, it is logic 1. For third combination, it is logic 1. For fifth combination, it is logic 1. For fifth combination, it is logic 1. Sixth combination and seventh combination. Now there will be a combination of 4, combination of 2, and combination of 2. Expression for F will be F equal to C plus A bar B bar plus AB. Now we'll see don't care condition. Suppose we have a function f which depends on two variable a and b, and we have its truth table as the function f has value 1 1 then 0 and or the function f for example it has value 0 1 and 0 cross. This cross represents that for this particular combination this f function is not defined, means a and b both simultaneously cannot be one. If they become one, output will be uncertain. It can be either 0 or 1, so it will be written as with cross. And in terms of function, that is written as summation m. For first combination it is logic 1 plus summation d. For third combination it is don't care, means output is uncertain. So now the K map will is called as, so sorry, this is function of two variable only. Sorry, function of two variable only. 0 1 0 1. For this first combination it will be 1. For third combination it will be don't care. For other two combination it will be logic 0. Now in the K map this don't care can be used as logic 0 or logic 1. This is single one, we can form a single, but according to the definition of K-map we should make pair of largest size, or we make a combination of largest size. So this don't care adjacent to the one can be used as logic 1 and a pair can be formed instead of a single. So expression for f can be written as f equal to b. Now next we will see a four variable K-map. Suppose a function f depends on four variable a, b, c and d. If there are four variable, total 2 raised to power 4 equal to 16 combination will be there. If there are 16 combinations, for 16 combination there should be 16 blocks in the K-map. So for four variable K-map there will be 16 blocks. We'll take one example. F is function of a, b, c, d equal to summation m 0 1 3 5 7 8 9 10 11 13 and 15. For all these combination the function has value logic 1. Now four variable came up, the MSB will be here and LSB will be on this side. Now in this four variable K-map there will be 16 combination and combination will be plotted like this. 0 1, again this block will be, this column will be left and then covered. This was like a 3 variable K-map, and for 4 variable K-map the third row is also left. 7th 8 combination will be a 9th 10th 11th 12th 13th 14th and 15th. Now all the blocks will with logic 1 will be filled. Now there are 8 ones adjacent to each other, so there will be a combination of 8 which will be called as octet, and there will be a combination of 4 1, this 4 1 combination, and for this expression will be written as f equal to, sorry, we have one more one here, and to cover this one we will have these 4 ones adjacent to each other. So there will be 3 combination, 2 quads, 1 octet, and expression will be written as f equal to a b bar plus b bar c bar. Now take one more example. For all the given combination, the output will be logic 1 and will be plotted in the K-map. Now these 4 ones are adjacent to each other, will form a quad. These 4 ones will again form a quad. There can be one quad, but again to cover this one we will have to form a pair. So we will form only a pair. The quad will be redundant. In this case, the f will be written as a bar c bar plus b bar c bar plus a b d. Now we will take one example for max terms. Suppose a function f is given f of ab equal to pi m 0 1 3, means all these combination have output logic 0. For this we have to find the expression. The expression will be obtained in POS form this time, 0 1 0 1. Remember one thing, that for POS expression this 0 will represent B and this 1 will represent B bar. This 0 will represent A and this 1 will represent A bar. Now for zeroth combination output is logic 0, for first combination output is logic 0, and for third combination output is logic 0. There will be two pairs. Now f can be written as f equal to, for this pair A is 0 means A, and for this pair B is 1 means B bar. The expression will be A plus B bar. Sorry, there will be AND operator in between them. This will be one, this will be one term. In between them, there will be AND operator.